Imagine standing on the deck of a fragile vessel, thousands of miles from the nearest coastline, surrounded by an endless, shifting horizon. There is no compass to guide you, no map to dictate your path, and no satellite to locate your position. You are utterly alone in the vastness of the Pacific. Yet, you are not lost. You are following a path mapped by the stars, the currents, and the migratory patterns of the sea. A path known only to you and your ancestors. Welcome to About Untold History. I am Elias Untold Vance, and today we are stripping away the veneer of modern technology to reveal the ancient, visceral intelligence that once allowed humanity to conquer the world's most hostile environments. From the shifting dunes of the Sahara to the infinite blue of the open ocean, we are going to explore the hidden geometry of the past, proving that before we had machines to guide us, we had something much more powerful. An intimate, unbroken connection to the pulse of the earth itself. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. To understand how the ancients navigated without the aid of modern instruments, we must first suspend our reliance on the digital and mechanical crutches that defined the 21st century. The foundational premise of pre-instrumental navigation was not the calculation of coordinate systems, but the total assimilation of the environment into the navigator's own cognitive framework. Ancient explorers, whether they were the master wayfinders of the Pacific or the nomadic pathfinders of the Great Arabian Desert, operated under a paradigm of environmental resonance. They did not view the sea or the desert as a void to be crossed. They viewed it as a complex, readable landscape where every wave, every breeze, and every star had a specific, distinct meaning. This segment investigates the biological and psychological architecture of this intuition. The human brain, when unburdened by the artificial constraints of modern GPS technology, exhibits a remarkable capacity for spatial orientation, a skill that we have largely allowed to atrophy. In the Polynesian tradition, this was not merely a learned craft. It was a sensory immersion. Navigators would spend decades learning to interpret the heave of the ocean, the subtle rhythmic vibrations caused by distant land masses reflecting swell patterns. They could sense the difference between a local current and a swell that had traveled thousands of miles across the deep basin. This required a level of concentration that borders on the meditative. It was an active dialogue with the planet. In the deserts, the method was similarly holistic. The Bedouin navigators used a technique known as reading the landscape, where the orientation of sand dunes, the specific texture of the soil, and even the behavior of the wind during the cooling of the night provided constant feedback on their heading. They were calculating the Earth's geometry using the only supercomputer available to them, their own minds. This natural compass was bolstered by an encyclopedic knowledge of celestial mechanics. Long before the sextant or the chronometer, ancient astronomers possessed a granular understanding of stellar movement that would put many modern observers to shame. They didn't just know the names of the constellations. They knew the precise timing of stellar risings and settings, effectively turning the night sky into a vast rotating grid. This was the birth of observational science. The stars acted as a stationary frame of reference against which the movement of the Earth could be calibrated. The brilliance of these ancient systems lies in their simplicity and their absolute reliance on the permanent features of our world: the sun, the moon, the planets, and the underlying geology of the land and sea. Elias Untold Vance emphasizes that this era of exploration was defined by a profound, almost spiritual intimacy with the natural world. It was not a battle against nature, but a surrender to its patterns. By harmonizing their physical movements with the larger physical cycles of the planet, these explorers achieved a degree of accuracy that still puzzles modern cartographers. We are not looking at primitive guesswork. We are looking at the pinnacle of human cognitive adaptation. Throughout this series, we will unpack the specific techniques that allowed these individuals to survive where others would have perished, beginning with the foundational concept of sensory awareness. We have forgotten how to see the world. The ancients, however, saw it with a clarity that defined the very limits of the habitable world. Their legacy is not just one of movement, but of a deep structural understanding of how we interact with our environment, an understanding we are only now beginning to reclaim. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. In the pre-modern era, the night sky was not a mysterious canopy of distant lights. It was a reliable, rotating clockwork that governed every aspect of long-distance survival. The transition from terrestrial observation to celestial navigation marks the second, most significant leap in the evolution of our pathfinding capabilities. While the previous segment highlighted the role of environmental resonance, this segment focuses on the star talkers, the highly trained navigators who codified the heavens into a sophisticated, mental navigational grid. By learning to recognize the cyclical rising and setting of specific pathfinder stars, these explorers could maintain a consistent heading across thousands of miles of featureless ocean or arid landscape. This was the birth of true astrometry, long before the invention of the telescope or the mathematical frameworks that define modern astronomy. The precision of this system rested on the concept of the star path. Polynesian wayfinders, for example, identified a series of stars that followed the same arc across the sky. By knowing exactly where a star rose and where it set, they established a set of directional gates on the horizon. If a chosen star was rising at a specific point on the horizon, the canoe was aligned with that bearing. When that star climbed too high, the navigator would switch their attention to another star that was rising at the exact same bearing, effectively creating an unbroken celestial highway. It was a sophisticated sequential handover of data that required memorizing hundreds of stellar positions and their seasonal variances. This was not merely navigation. It was the memorization of a dynamic, three-dimensional geometry that existed only in the mind. In the Sahara, the approach was slightly different, but equally brilliant. Caravaneers utilized the meridian transit, observing when a star crossed the highest point of the sky. By measuring the angle of this transit relative to the horizon, they could estimate their latitude with surprising accuracy. This knowledge was guarded as closely as state secrets, passed down through oral traditions, rhythmic chants, and mnemonic devices that encoded astronomical data. These weren't just stories. They were compressed data files designed to ensure that even in the middle of a sandstorm, a navigator could reconstruct their position relative to the North Star or the Southern Cross. It was a fusion of art and science that allowed humanity to transform the chaotic randomness of the night into an orderly system of travel. Elias Untold Vance notes that this era of exploration highlights a critical cognitive shift: the ability to abstract the world. To use the stars as a map is to detach oneself from the immediate, tangible environment and link it to the cosmic scale. It represents the moment humanity stopped being reactive to the landscape and started being proactive in conquering it. We learn to rely on the fixed points of the universe, the stars, to guide us through the changing points of our own world. This mastery of the celestial grid is a testament to the incredible plasticity of the human intellect. As we move deeper into this series, we will see how this abstract knowledge of the stars was combined with the physical study of ocean currents, creating a dual-layered system of navigation that remained unmatched until the industrial age. The Star Talkers did more than guide their ships. They expanded the boundaries of human existence, turning a vast, terrifying universe into a navigable home. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. If the stars provided the roadmap of the celestial heavens, the ocean itself provided the physical ground truth. To the uninitiated, the surface of the open sea appears as a chaotic, unpredictable tapestry of rolling waves. However, to the master navigators of the Pacific, the ocean was a sophisticated data streaming device. This third segment explores the science of wave dynamics, the art of reading the pulse of the ocean. Polynesian voyagers in particular achieved a level of mastery over oceanic swells that remains one of the most remarkable feats of pre-instrumental science. They recognized that the sea was not merely a local phenomenon. It was a global, interconnected system where energy moved in predictable long-distance patterns. The key to this method was the ability to distinguish between wind waves and ocean swells. Wind waves are local, choppy, and chaotic, created by the immediate weather conditions in the navigator's vicinity. Ocean swells, by contrast, are generated by distant storms or consistent global wind patterns, like the trade winds, that travel thousands of miles across the deep basins. These swells carry the memory of the distant land or weather systems that created them. An experienced navigator could feel the rhythmic heave of the vessel, the pitch, the roll, and the subtle secondary vibrations, and identify exactly which swell was originating from which distant source. It was an exercise in extreme tactile sensitivity. When these swells encountered a landmass, they would be refracted, reflected, or diffracted, creating complex interference patterns that were invisible to the untrained eye, but clearly decipherable to the master wayfinder. This complex interaction of wavefronts served as a diagnostic tool for land finding. When a primary swell collided with an island, it created a backscatter or a shadow zone that could be sensed up to 30 or 40 miles away from the coast. The canoe would act as a sensor, with the navigator feeling the dampening of the wave energy or the sudden change in the vessel's buoyancy. They were, in effect, detecting the physical presence of land through the alteration of fluid dynamics. This allowed them to see an island long before it appeared on the horizon, essentially extending their sensory reach far beyond the limit of human vision. It was a fusion of hydrodynamics and biological intuition that turned the vast, empty ocean into a terrain of identifiable landmarks. Elias Untold Vance observes that this segment represents the ultimate union of the observer and the environment. There is no separation between the navigator and the vessel. The boat becomes an extension of the navigator's own body. Every subtle movement of the hull is interpreted as a piece of data, a signal from the planet itself. This is the antithesis of the modern black box navigation, where the data is processed by a machine and presented to a passive user. Here, the navigator is the machine. The study of wave dynamics was not just about finding land. It was about understanding the fundamental energy flow of our planet. As we continue this series, we will see how this tactile knowledge of the water was integrated with the celestial data we discussed in the previous segment, creating a dual-layered reality that allowed ancient humanity to map the globe with a precision that was, for centuries, considered impossible. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Beyond the celestial stars and the rhythmic pulse of the ocean, the ancient pathfinders possessed a third, equally critical layer of data: the biological map. For an explorer navigating the trackless voids, nature was not merely the environment through which they traveled. It was a dense, encrypted library of clues. This fourth segment explores the sophisticated biological cartography that allowed ancient navigators to read the behavior of flora and fauna as precise indicators of proximity to land. In the vast, featureless Pacific or the daunting expanse of the Sahara, where traditional navigation might fail, the subtle shifts in the behavior of birds, fish, and even the scent of drifting vegetation served as the ultimate forensic evidence of a nearby shore. This was a mastery of ethology, the study of animal behavior applied to the existential necessity of survival. The most famous of these techniques involved the tracking of pelagic bird species. Navigators knew that certain birds, such as frigatebirds or terns, had specific foraging ranges. By observing the flight direction of a bird at dawn, when it was heading out to feed, and at dusk, when it was returning to its roost, an explorer could triangulate the direction of the nearest island with remarkable precision. This was not random observation. It was a systematic application of ecological knowledge. They understood the species-specific flight altitudes, the speed of wing beats, and even the types of fish these birds carried in their beaks. If a bird returned with a specific type of reef fish, it told the navigator not only where the island was, but what kind of ecosystem they were approaching. They were reading the intentions of nature to calculate their own heading. In the desert environments of the Sahara or the Arabian Peninsula, the biological map took on a different form. Here, the indicators were insects, migratory land birds, and the subtle variations in plant life that marked the edge of an oasis. Caravaneers looked for the presence of specific pollinators or the migration patterns of desert locusts, which often followed the path of least resistance through the dunes. Even the scent of a wind blowing off a distant scrubland could be interpreted as a sign of impending vegetation. This was a sensory cartography that turned every living creature into a navigational beacon. It was a holistic view of the ecosystem, where the navigator understood their own position as just one node in a larger, interconnected web of life. Elias Untold Vance notes that this segment reveals the true nature of ancient intelligence. It was profoundly observation-based and inherently interdisciplinary. To be an explorer was to be a biologist, a meteorologist, and a navigator all at once. There was no compartmentalization of knowledge. They understood that the ocean and the desert were not empty, but filled with life that followed strict, logical, and predictable patterns. By aligning their human survival strategy with the established patterns of other species, they turned the entire planet into a navigable map. As we look at these ancient methods, we see that modern technology has blinded us to these signals. We have traded the ability to read the living language of nature for the artificial certainty of digital coordinates. Yet, the signals are still there, written in the flight of a bird or the migration of an insect. A reminder that we are part of a world that is constantly speaking to us, provided we know how to listen. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. If the stars are the masters of the night, then the clouds are the masters of the day. In the fifth stage of our exploration, we turn our gaze toward the atmospheric canvas. To the modern observer, clouds are merely weather indicators. To the ancient navigator, they were topographical signposts. This segment delves into the geometry of silence, the systematic interpretation of cloud formation, color, and behavior that allowed explorers to map hidden landmasses while still miles beyond the horizon. Atmospheric navigation was perhaps the most subtle of all ancient skills, requiring a near superhuman ability to differentiate between transient weather systems and the permanent footprints cast by islands upon the sky. The primary phenomenon utilized here is orographic lift. As prevailing winds strike an island, the air is forced upward, creating distinct cloud formations that differ sharply from the surrounding oceanic sky. These are not random clouds. They are the physical manifestation of the island's topography. A master wayfinder could look at a cumulus cloud and discern, by its shape, density, and stability, whether it was anchored to a landmass or simply a drifting pocket of moisture. They looked for the green reflection, the subtle emerald-tinted glow on the underside of low-lying clouds, caused by the reflection of light off a shallow coral lagoon or a lush forest canopy. This was a form of remote sensing that functioned with the precision of modern satellite imaging, but was entirely dependent on the naked eye. Furthermore, cloud patterns told the story of the sea's temperature. A navigator could identify an approaching island by the way the clouds addered or shredded at their edges. The different thermal signatures of land versus water caused the air to behave in specific, measurable ways. By observing how clouds dissipated or gathered around a particular sector of the horizon, the navigator could identify the shadow of an island long before the island itself became visible. This was a science of invisible signatures. It required the navigator to understand the interaction between heat, pressure, and moisture, the thermodynamics of the atmosphere, without ever having seen a textbook on physics. Elias Untold Vance posits that this level of observation represents the absolute peak of ancient environmental integration. The navigator did not look at the sky. They read it, analyzing the atmosphere as a fluid, dynamic dataset. This was the original big data analytics, processing thousands of hours of visual input to predict the future state of a hidden landscape. We often speak of the ancients as living in a state of unconscious harmony with nature, but this is a gross misconception. Their navigation was a hyperconscious, highly trained analytical practice. As we move through this segment, we are confronted with a sobering reality. We have lost the ability to observe the sky with this level of functional intent. We look up and see weather. The ancients looked up and saw a map. By reclaiming this perspective, we begin to understand how humanity transformed an alien, hostile planet into a structured, navigable, and deeply familiar home. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. In the absence of written charts, the ancient navigator's primary storage device was the human memory. This sixth segment investigates the oral archive, the sophisticated system of songs, chants, and linguistic constructs used to encode massive amounts of geographic data. For cultures like the Australian Aboriginals, who utilized songlines, or the seafaring Polynesians, who used complex oral epics to record archipelagos, knowledge was not kept in a library. It was kept in the mind, mapped onto the landscape through rhythm and melody. This was a form of auditory cartography. By turning a voyage into a song, the navigator created a durable, portable, and easily retrievable record of every reef, current, and landmark they encountered. A songline is far more than a myth. It is a highly literal melodic map. Every verse of a traditional chant corresponds to a specific physical feature in the landscape: a rock formation, a waterhole, or a change in the coastline. As the navigator sings the song, they are effectively traversing the path in their mind, moving from one verse landmark to the next. The rhythm of the chant dictates the pacing of the journey, ensuring that the traveler maintains the correct speed and timing between major waypoints. It is an algorithmic approach to memory. If you sing the song correctly, you will arrive at the destination safely. This system allowed for the transmission of survival data across thousands of years with startlingly low error rates, demonstrating that oral tradition was an incredibly stable technology for information storage. In the Pacific, these navigational chants were even more complex. They incorporated meteorological and astronomical data, acting as a rhythmic computer that helped the navigator recall the seasonal behavior of the stars, or the specific swell patterns associated with certain islands. By embedding the data into the structure of a song, which utilizes rhyme, alliteration, and repetitive structure, the information becomes sticky, resistant to corruption or loss over generations. This wasn't just storytelling. It was a rigorous, error-correcting code. A navigator who misremembered a verse was corrected by the collective, ensuring the survival of the entire crew. It was a shared, communal database that turned every member of the tribe into a potential record keeper. Elias' Untold Vance reflects that this segment challenges our modern bias toward external data storage. We assume that writing and digital hardware are superior to the mind, yet these oral archives functioned for millennia without the risk of battery failure, hardware degradation, or the need for electricity. The oral archive was built directly into the biological substrate of the human brain, utilizing our innate capacity for musical and rhythmic learning. It represents a profound harmony between human cognition and the geography of our planet. As we delve further, we see that the ancient navigators' greatest tool was not an instrument, but their ability to transform their own consciousness into a vessel of knowledge. Their maps were not on paper. They were in their voices, carried across the world as a living, breathing song. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Having explored the celestial, oceanic, biological, atmospheric, and mnemonic layers of ancient navigation, we must now address the most profound element of all, the cognitive mechanism that bound these diverse streams of data into a singular, functional whole. This seventh segment explores the cognitive compass, the neurological transformation that occurred within the minds of master navigators. They did not just process information. They lived inside a constantly updating four-dimensional model of their surroundings. This was a form of spatial cognition that modern psychology is only just beginning to map. While a modern traveler relies on a map to represent the world, the ancient navigator became the map. This was not a passive mental state. It was a high-intensity, executive function that operated continuously, even during sleep. The process began with the creation of a fixed frame of reference. Whether at sea or in the desert, the navigator maintained a mental coordinate system that was independent of their own movement. If the ship turned, the navigator did not rotate their internal map. They updated their position within it. This is a complex form of dead reckoning that relies on a constant integration of speed, time, and direction. By internalizing the movement of the stars, the rhythm of the waves, and the shifting of the sun, the navigator maintained a constant, real-time awareness of their distance from their point of departure and their bearing toward their destination. They were, in essence, performing continuous differential equations in their head, calculating the Earth's curvature and their own trajectory across the planetary surface. This internal grid was deeply tied to the body's proprioception, the sense of self-movement and body position. Navigators did not just see the world, they felt it. The pitch of the vessel was not a distraction, it was a data point. The subtle shift in the wind's temperature on the skin was not an environmental condition. It was a navigational signal. This multi-sensory integration allowed them to maintain their cognitive compasses even in zero visibility conditions, such as during a heavy storm or a thick Sahara sandstorm. When the visual input was stripped away, the mental model remained, perfectly calibrated and fully operational. This is the ultimate testament to the plasticity of the human mind. Our ability to externalize our consciousness into the environment and internalize the environment into our consciousness. Elias Untold Vance notes that this cognitive achievement represents a level of human adaptation that technology has actually allowed us to weaken. By outsourcing our sense of direction to GPS and satellite arrays, we have effectively decommissioned the part of our brain that was once capable of holding the world in its totality. The ancient navigator's cognitive compass was a muscle that was exercised every day, reinforced by a culture that demanded precision and rewarded the mastery of the unseen. As we continue this series, it becomes clear that the untold history of exploration is not just the story of moving from one place to another. It is the story of how our minds expanded to contain the vastness of the planet. We did not conquer the world with machines. We conquered it by becoming so deeply attuned to its geometry that we could move through it with the confidence of an architect walking through their own home. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. While the primary tools of the ancient navigator were biological and cognitive, they were not entirely devoid of physical instrumentation. In this 8th segment, we explore the engineering of survival, the ingenious, often overlooked physical mnemonic aids that supported the navigator's mental workload. These were not GPS devices. They were low-tech, high-concept tools designed to stabilize the navigator's focus and provide a tangible reference for complex calculations. From the Polynesian star compasses, the star circle, to the Inuit sunboards and the stick charts of the Marshall Islands, these artifacts represented a bridge between abstract knowledge and physical reality. They were designed to offload specific data from the mind, acting as a backup memory that could be consulted during the long, arduous nights of a transoceanic voyage. The Marshallese stick chart, or matang, is perhaps the most famous example of this sophisticated engineering. Constructed from the midribs of coconut fronds and shells, these charts were not maps in the modern sense. They were pedagogical devices used to teach the patterns of ocean swells and how they interacted with island shadows. They were not taken on the voyage, but rather studied before departure to encode the rhythm of the ocean into the navigator's mind. Once the navigator was at sea, the chart remained on land, their brain having become the map itself. This distinction is crucial. The tool was not the guide. The tool was the teacher. This represents a profound philosophy of learning, where the physical object is used to cultivate internal mastery rather than replace it. Similarly, other cultures developed horizon boards or simple wooden slats that allowed navigators to measure the altitude of a star by aligning it with the edge of the board. This was a primitive yet highly effective sextant, allowing for the consistent monitoring of latitude. These devices were stripped of all unnecessary complexity, designed to be durable, lightweight, and operable in the harshest conditions. Saltwater, sand, and gale-force winds. They were the product of centuries of iterative design, where every notch, every curve, and every shell had a specific functional purpose. This was minimalist engineering at its finest, proving that the most effective tools are often those that require the least amount of maintenance and the highest amount of user skill. Elias Untold Vance emphasizes that these tools reveal the practical brilliance of ancient exploration. We often assume that the lack of complex machinery equates to a lack of engineering capability. But these aids were perfectly tailored to the environment and the task at hand. They demonstrate a deep understanding of physics, geometry, and materials science, applied to solve the most critical problem of the ancient world: how to maintain a consistent trajectory across the unknown. As we study these artifacts, we are not looking at primitive toys. We are looking at the foundational ancestors of modern flight computers and navigational interfaces. The history of technology is not a linear march toward greater complexity, but a circular journey toward the most elegant, efficient, and reliable way to interface with the world. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. Navigation is rarely a task of perfect certainty. It is an ongoing exercise in managing the unknown. In this 9th segment, we examine the psychology of uncertainty, the mental framework that ancient explorers used to process risk, maintain morale, and critical decisions when the data became ambiguous. Crossing thousands of miles of open ocean or arid dunes is not just a physical journey. It is a profound psychological test. The primary challenge was not the environment itself, but the void, the silence of a featureless horizon that could easily trigger despair, hallucination, or catastrophic errors in judgment. Ancient navigators were, therefore, as much psychologists and philosophers as they were cartographers. The core of their risk management strategy was a concept known as probabilistic thinking. While modern navigators use software to calculate the probability of success, the ancients utilized a form of intuitive Bayesian inference. They constantly updated their confidence in their position based on new, incoming data, the change in a wave's frequency, the sighting of a specific species of bird, or a slight shift in the star's rising points. If the data contradicted their expected path, they did not panic. They recalculated their mental hypothesis. This required an immense degree of emotional regulation. They were trained to detach their personal fear of death from the technical necessity of the task. The survival of the crew depended on the navigator's ability to remain calm, objective, and analytical, even when the margin of error was zero. Another critical component was the collective management of risk through shared cognitive load. Navigation was rarely a solitary act. It was a communal responsibility. The navigator, the rowers, and the scouts were all linked by a common operational language. In the Pacific, this included standardized chants that everyone on the boat understood, ensuring that the crew remained synchronized with the navigator's intent. If the navigator sensed a shift in the currents, the crew shifted the vessel's trim before being told. It was a form of distributed intelligence where the ship operated as a singular organism. This shared rhythm reduced the individual stress on the navigator, allowing them to focus on the high-level geometry of the voyage while the crew managed the immediate physical variables. Elias Untold Vance observes that this psychological resilience is the most untold part of our history. We admire the courage of the explorers, but we rarely examine the rigorous training that made that courage possible. They did not enter the void by hoping for luck. They entered it by mastering their own nervous systems. They understood that the mind is a delicate instrument, susceptible to bias and fatigue, and they built social and technical safeguards to protect it. As we look at the psychological infrastructure of these ancient journeys, we see a model of resilience that is still applicable today. When we face the uncertainties of the modern world, the unknowns of the future, the complexity of global systems, we can learn from the ancient navigator. The key to surviving the void is not to ignore the uncertainty, but to create a mental and social framework that allows us to navigate through it, one observation at a time. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. If the navigator's mind was the data storage, then the culture was the operating system. In this 10th segment, we explore the architecture of transmission, the rigid, ritualized social structures that ensured navigational knowledge survived for thousands of years without ever being written down. How do you prevent a complex, multi-dimensional dataset from decaying as it passes from one generation to the next? The ancients treated information as a sacred, high-value asset, protected by elaborate initiation rites, hierarchical schooling, and the institutionalization of the wayfinder as the highest social caste. This was not a casual transfer of skills. It was an exacting, lifelong apprenticeship designed to eliminate the possibility of human error. The training of a navigator began in early childhood and often lasted decades. It was structured in layers of increasing complexity. First, the memorization of star patterns. Second, the rote learning of songs that encoded coastal features. Third, the mastery of tactile wave sensing. And finally, the psychological training for life or death decision-making. These stages were often marked by formal initiations, where the apprentice had to demonstrate their knowledge under extreme physical and mental pressure. By making the transmission of knowledge a sacred duty, these cultures guaranteed that only the most capable, dedicated, and emotionally stable individuals would ever command a vessel. It was a rigorous filter that maintained the integrity of the archival data across millennia. Furthermore, this knowledge was compartmentalized to prevent the telephone game effect, where information becomes corrupted through retelling. Different guilds held different parts of the map. One group might specialize in celestial mechanics, another in current dynamics, and a third in biological indicator species. The master navigator was the one who could integrate these separate, highly specialized streams of knowledge. This prevented the loss of information through the death of a single individual. The data was distributed across the community, functioning as a decentralized, fault-tolerant network. If one expert died, the backup existed within the collective memory of the group. Elias Untold Vance notes that this architecture of transmission offers a radical critique of our modern educational systems. We emphasize broad, shallow knowledge. The ancients emphasized deep, domain-specific mastery. They understood that information has no value if it is not accurate, and accuracy is only preserved through institutional discipline. In our digital age, we have outsourced our memory to the cloud, making us fragile. If the systems fail, the knowledge disappears. The ancient world, by contrast, built the knowledge into the social fabric itself. They didn't just teach people how to navigate. They built a culture that functioned as a living, breathing, and permanent library. As we reach the penultimate segment of this series, we realize that the most remarkable achievement of the ancients was not the distance they traveled, but the sheer durability of the wisdom they left behind. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. As we reach the 11th segment, we transition from the history of navigation to its enduring legacy. We have traveled through the celestial, the oceanic, the biological, and the cognitive, observing how ancient wayfinders bridged the gap between human limitation and planetary vastness. Now we must ask, what happens to this knowledge when the world changes? The history of the wayfinder is not a closed chapter. It is a profound critique of our modern technocentric existence. Today, we exist in an era of perfect navigation, where a satellite can pinpoint our position to within a few centimeters. Yet, in this state of digital omniscience, we have effectively lost the capacity to understand the world as a direct, sensory experience. We have traded the intimacy of the navigator's intuition for the absolute, yet detached, authority of the machine. The echo of the wayfinders is found in the sudden, often uncomfortable realization of our own technological fragility. When the grid goes down, when the GPS signal is lost, or the battery dies, or the algorithm makes a fatal assumption, what remains? The ancient navigator was always on, because their brain was the grid. They were never lost because they were always in relationship with the environment. Modern humanity, conversely, is frequently lost, even when the digital map tells us exactly where we are, because we have lost the ability to read the terrain. We have become passive passengers in our own lives, relying on a digital black box that we do not understand and cannot repair. The lesson of the wayfinder is not that we should abandon technology, but that we must not allow it to supersede our own capacity for observation and judgment. This segment invites us to consider a hybrid navigation for the future. As we grapple with the immense challenges of the 21st century, climate change, global instability, the rapid evolution of artificial intelligence, the wayfinder's mindset offers a vital alternative. It is a mindset that values precision, deep observation, and the ability to integrate diverse data streams into a single, cohesive reality. It teaches us that truth is not something delivered to us on a screen, but something we must actively synthesize through our own engagement with the world. We are living in a new kind of void, a digital ocean of infinite, often contradictory information. To navigate this, we need the ancient discipline of the wayfinder, the ability to filter the signal from the noise, the patience to read the subtle signs of systemic change, and the courage to trust our own cognitive compass when the sensors fail. Elias Untold Vance notes that this segment is the most personal of the entire series. It forces us to confront our own intellectual dependency. We are not just navigators of space, we are navigators of meaning. The Wayfinder was successful not because they had the best map, but because they had the most refined relationship with reality. As we move toward the final segment, the takeaway is clear. The history of exploration is, at its heart, the history of human attention. By choosing where we focus our awareness, we create the world we live in. We can choose to be passive consumers of data, or we can choose to be active navigators of our own existence. The stars, the birds, and the waves are still there, speaking in the same ancient language, waiting for us to stop looking at our devices and start listening once again. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey. We have traveled across the vastness of the sea, the desert, the mind, and the archive. In this final segment, the uncharted future, we arrive at the culmination of our journey. The ancient Wayfinder's story was never truly about the past. It was a blueprint for the future. As we stand at the precipice of a new age, one defined by artificial intelligence, biotechnology, and planetary uncertainty, the lessons of the navigator become more urgent than ever. We are moving into an ocean of unknown variables that no algorithm can fully map. To traverse this future, we must stop being mere passengers of progress and become navigators of our own destiny. The ultimate takeaway of this series is that mapping is not an act of observation, but an act of creation. The navigator creates the path by observing the signs, interpreting the data, and committing to a course. Today, we are all tasked with this same responsibility. We are the architects of a global, human-made environment that has become as complex and unpredictable as the open ocean. If we continue to rely on external, fragile systems to tell us where we are and where we are going, we risk losing our way. But if we reclaim the cognitive compass, the deep, integrated awareness of our relationship with the planet, we unlock a power that no machine can replicate. The ability to discern, to synthesize, and to adapt. The path forward is a return to the source. It is the integration of high-level technological capability with the fundamental human capacity for direct, sensory interaction with reality. The future belongs to the hybrid navigator, the individual who understands the power of the algorithm, but trusts the intuition of the human experience. It is a future where we use our tools to enhance our perception, not to replace it. We must build technologies that help us see further, listen deeper, and understand the intricate systems of our world, while never forgetting that it is our consciousness that gives meaning to the journey. We are not lost. We are simply at the edge of a new horizon. Elias Untold Vance concludes this series with a final reflection. Exploration is not about finding new lands, but about transforming the way we see the lands we are already on. The untold history of the world is that we have always been navigators, and the future is simply the next stretch of the voyage. The stars, the tides, and the currents remain constant, but our understanding of them is infinite. As we close this chapter, the invitation is open. Look up, look out, and start reading the signs again. The map is not in your pocket. It is in your gaze. The voyage never ends. It only begins anew with every breath, every observation, and every step we take into the uncharted potential of our shared human future. Don't forget to subscribe to the channel, follow us, and turn on the notification bell to stay updated with our upcoming historical journey.